Knowing about the symmetry of graphs can certainly help when it comes to sketching the graphs. Because if you know about the symmetry, you really only need to sketch half of the picture, and then you can either reflect it or rotate it, depending on the type of symmetry that it has. The two main types of functions we have are odd functions, and the formal definition of an odd function, function negative x is equal to negative function x. So if you're asked to prove or show something as an odd function, you can't say, oh, by the picture I can see it's an odd function or something like that. You formally have to show that this result is true. But it does have symmetry, and it's that rotational symmetry or point symmetry about the origin. So 180 degrees, you spin it, it's going to look exactly the same. So S cubic is, yes, hyperbola is. In fact, when you're talking about polynomials, if all the powers are odd, then it is an odd function. But again, that's not good enough for a proof. You've still got to prove it using function negative x is equal to negative function x. So let's try it. Let's do x cubed plus x to the 7th. They asked me to do that. Then it's simply a matter of saying, well, I know function x, it's the one they've given me. Let's sub in negative x and see what happens. If I cube a negative number, it'll stay negative. If I raise it to the power of 7, it'll say negative. So I get negative x cubed minus x to the power of 7. I could factorise the negative out, and then inside the parentheses I have the original function. So yes, it satisfies function negative x is equal to negative function x. So that proves it is indeed an odd function. Well, there's also even functions. Even functions also have symmetry. Its formal definition is function negative x equals function x. So it has line symmetry. And so the y-axis is an axis of symmetry. Our classic parabola, x squared plus 4, if I shifted it up 4, it's still going to be an even function. And in fact, anything that has an even power, if we're talking about polynomials. Now, for the sake of even, we're thinking of 0 as an even number. So the constant 4 is like 4x to the power of 0. So we're going to prove that x squared plus 4 is indeed an even number. So same idea, there's the original function. Sub in negative x, let's see what happens. And we get negative x all squared. If I square a negative number, you get a positive number, so we get x squared plus 4, and that was the original function. So yes, it satisfies our requirement, so it is an even function. Okay, it's the first little bit of theory